Today, we're diving deep into, a massive shift happening right now in tech roles, the critical importance of AI engineering. Our sources are calling this one of today's most valued skills. We'll be looking particularly at a program called the AI Engineer, or TAE, which claims to offer a path into this field. So, what's really driving this huge demand?
Well, we need to set the scene a bit. What's really fascinating, I think, is how these large AI systems, LLMs, code helpers, chatbots, they're actually starting to automate a lot of that traditional entry-level stuff.
You mean like drafting emails, basic docs, that kind of thing?
Exactly. Writing boilerplate code, simple documentation. And when AI handles those junior tasks, it just instantly raises the bar for everyone else. The skill that becomes essential then is, well, the ability to build and operate reliable AI features, stuff that actually works in production. That's the real shift. AI engineering is suddenly the bottleneck.
Hmm. And the sources we looked at, they definitely back up the urgency here. We're seeing headlines about a pretty intense talent war. I mean, nine-figure compensation packages for top researchers. Is that just hype around a tiny number of people, or is this really a once-in-a-generation opportunity for, regular engineers?
It's a bit of both, honestly. Okay, maybe nine figures are for the absolute superstars, yeah. But those headlines, they point to a very real, very persistent gap between supply and demand. Organizations are genuinely struggling. They want to deploy AI, but they often lack the internal engineering capability, not just the research wizards.
Right.
And that creates a huge opportunity for you, whether you're maybe just starting out, a student, or already working, because this gap is structural. As those more junior roles get automated away, the demand for senior folks, people focused on production, it just explodes.
Okay, so if the mission is creating these production-focused engineers, how does this TA program tackle that? They talk about going from zero to production, and they really emphasize making everything collab ready with no setup required. How do they get learners up to speed so quickly? Seems like a big promise.
Yeah, the speed factor comes from cutting out that initial headache, right? The setup, the configuration, managing dependencies, that stuff can really slow you down. So try to remove that friction. The curriculum itself uses what they call a dual track approach. It aims to bridge the theory and the actual practice.
Okay, dual track. Tell me more.
So you've got the core track that lays down the foundations, Python, PyTorch, deep learning fundamentals. It even goes into building an LLM from scratch, apparently.
Wait, hold on. If the core track covers PyTorch and LLMs, how is that different from, say, a standard data science boot camp? What makes this other track, the engineering track, distinct?
Ah, good question. That engineering track,
Yeah.
it's laser focused on the, let's say, the messy reality of getting things into production. We're talking really critical skills here. Testing your models, packaging them up, CI/CD pipelines, containerization, things that make software actually work reliably.
Okay, the practical stuff.
Exactly. If you build a great model but can't deploy it reliably, well, it's basically useless, right?
Hmm.
The program also dives into more advanced but crucial topics like observability and cost control.
Observability, yeah, that seems absolutely critical with AI. It's not like you just build it once and forget it.
Precisely. You hit the nail on the head. Models drift, they encounter weird data in the real world, they fail. Observability gives you the visibility to see what's happening. You need to monitor, diagnose problems, maintain the system running in the cloud. That operational insight, that's a big part of what separates, a researcher from a true engineer. The whole thing seems quite systematic. It leads to these GitHub-ready capstone projects, apparently resulting in over 30,000 lines of code for your portfolio.
That portfolio aspect sounds huge, especially for students or maybe academics trying to get that practical fluency quickly. What about for people already working? How flexible is the learning path?
Yeah, flexibility seems key. The sources mention three different paths. There's a really intensive 4-week fast track, then a medium track spread over 8 weeks, maybe better balanced if you have a job, and finally a self-paced option that gives you up to 6 months.
And thinking bigger picture, this sounds like a pretty major strategic opportunity for companies too, right? Instead of getting caught in those crazy talent wars,
Exactly.
they could use something like this to build in-house capability.
Precisely.
Right.
Train your existing engineers, your data teams. Get them skilled up in cohorts. You skip the expensive, time-consuming hiring battles. And crucially, doing it this way helps establish shared standards across teams, code practices, deployment methods, tooling. That makes large-scale AI deployment way more efficient and maintainable.
Okay, so let's try to wrap this up for the listener. What's the main takeaway here? It sounds like TAE offers a structured path, starting with fundamentals, but really pushing towards that production focus, giving you the practical skills that seem to matter most right now.
Yeah, and if you connect it back to that bigger picture we started with, well, given that AI systems are automating away more routine tasks, it feels like the most secure path forward professionally is to become one of the people who actually build and operate these complex systems, the ones who make AI reliable in the real world.
Right. So, with their first cohort apparently starting November 3rd, 2025, here's a final thought for you to chew on. In this landscape, how quickly can you really afford not to get the skills needed to build reliable AI features end to end?